Let's say I took a test for AP Bio and I want to know the average score. But for privacy reasons, my AP Bio teacher won't tell me the average. So instead what I do is I ask a couple of my friends and I get, these scores. So I find 34, 57, 64, 65, 80, 88, and 92. So I asked 7 of my friends. There are 7 pieces of data here, and I want to find the average. We all know how to find the average. You just add them all together and then divide by 7. To make this easier to understand, let's say we wanted to find the average of 7 and 9. Clearly the average is 8 because 8 is in the middle of them. But what you do is you add them up and divide by 2. This is kind of like finding the midpoint. And this gives you 16 divided by 2, which is 8. Checks with our intuition, okay? And same thing with more data points. But if I just told you what the average was, which I think it is about 66. Okay, no, it's 68. That wouldn't tell you much, right? Because there's so much variation, no? We have, our scores vary from 34 to 92. If I just told you the average, that wouldn't mean anything, right? So we need a way to figure out, on average, how far apart are the data values from each other? Or, on average, how far does the data vary from the mean? The mean is the average. So let's say that's called standard deviation. There's a formula for standard deviation if you have all the test scores, right? But we only have some of the test scores. And I'll tell you why that's important. So let's derive it, right? So let's say we just have one data point, right? No, let's say we have 2 data points, 7 and 9. The average of them is 8, okay? So on average, how far is each data point from the mean, the average? Well, they're each 1 away, so the standard deviation is 1, okay? Okay, so how could we turn this into a formula? Well, what did we do? Well, we took each data point, let's call each data point, let's use a variable. Let's call every single data point xi. So the first data point is x1, the second is x2, etc. And let's subtract the mean. So it's kind of like we want to take the distance, and this is the symbol for mean, between each data point and the mean. The thing is, though, this could be a negative number, right? And we don't like dealing with negatives in statistics because it doesn't really make sense to say oh yeah, the average distance from a point to the mean is -1. We like it to be a positive number. So, what's the word? So, we could square it, right? Because squaring something makes it positive. But, you can't just square it, you have to take the square root. Now, also, keep in mind, we're summing these up. So we're doing, right, the first data value minus the mean squared, plus the second minus the mean squared, etc., etc. And remember, we want to find the average of those distances, because it's kind of like we're calculating distance. So we divide by normally we would divide by the number of data points. But when we're calculating it when we only have a sample instead of the whole population, we divide by n-1. Sorry, this means to add, by the way, this little symbol. So, for example, here we know the mean is 68. So in this case, we'll do 34 minus 68 squared plus 57 minus 68 squared. And then there are 7 data points, so we'll divide by 6. There's a technical dot. And we'll take the square root of this whole thing. There's a technical reason why we divide by n-1, but you don't need to worry about it. Just know that we want to divide by a smaller number